Okay, so we're gonna get started here in just a minute or two. Can people nod if they can hear me just fine? Ah, nods, excellent. Okay, let me get that. Okay, so the gist of this is, as I'm rolling through the lecture, I have a second monitor up that has everyone's faces on it. I can see you nod. You can wave at me if I miss a question or something like that. What I'm going to ask is basically just that if you have questions, if they're short, type them in chat. I will see them and I will read them out so everyone who's listening on a recording can hear them. I'll respond to them. If you have longer questions or something pretty specific, you can use the hand raise feature over in the participants list over there. You can just hit raise hand and that will pop a notification to me, and then I'll unmute you so that you can hear, or so that I can hear and everyone can hear you, and then we'll go back and forth until you're good. Okay, so I'm gonna go ahead and get started. The way everything works in this class is that all content that I have for the class is found on this main public course website. So I have it up right now. Can everyone see my screen share? Nods. Perfect. Okay. So the course website, clanfear.github.io/CSSS508. Everything is there, including the slides I'm going to lecture off of, all that kind of thing. In fact, you'll see I'm actually just going to lecture straight off the website. I don't do anything else. Everything is self-contained there. So for the lectures, I'm just going to go ahead, drop down to today, click on it. I hit F, and we have some full screen lecture slides. Okay. So I assume everyone is in the right room today, that being their own rooms, because this is pandemic edition CSSS508. Okay, so I'm going to get right into it. So my goals for this course, I've been running this course a long time. I've sort of refined what I expect people to get out of it. What are the hopes I have for you? Hopefully these align with what you would like to get out of this course too. So my course goals are, first, to develop intermediate data management and visualization skills in R. So when I say intermediate skills, I do not mean beginner skills. I mean that you should be able to sit down with some kind of actual project that you get. Say you're RAing for a professor or something like that. Maybe you get some new job that requires actual analytics. You should be able to sit down and attack any new data set you encounter and feel relatively comfortable with it. This is not beginner, this is operative, real intermediate skills in management and visualization. The next thing is learning basic programming. So I say intermediate data management visualization, but basic programming. The level of programming you're going to get into in this class is relatively light. I am going to teach things like loops and flow control, which are the basic building blocks of most programming, but I'm not going to go super into details. A lot of things that if you're going to become a real software developer, you need to know a lot more than what we're going to cover in the class. But for most social scientists doing real research, those things are not as critical, so I don't spend that much time on it. Next, I'm going to introduce reproducible research practices. So this is something that you're going to learn more or less by accident in this class, because all of the homeworks you turn in this class must be turned in as fully reproducible research documents, where everything necessary to take the raw data and produce your analyses are self-contained in a single document. So it's all documented. You could prepare journal articles in the exact same format you'll turn your homeworks in. I, in fact, do that myself. You learn all that stuff in this class, mostly as a side effect of just turning in your homeworks. Turns out it's really easy to do, and people should generally be doing this. Next, I want to prepare you for statistics and CSSS courses. So this course exists because in the past, statistics and CSSS courses tended to just have you enter, learn a bunch of stats, and then throw you to the wolves for the actual programming part of it, which is ridiculous. Because actually writing code, if you've never done any programming before, is really hard. Stats classes are also really hard. So what you get is one thing that's really hard you're actually being taught in, and some completely separate, really hard thing that no one is teaching you anything about, or they're teaching you badly. That is a really bad model. And so my class exists to try and head that off a little bit. Hopefully you haven't suffered through too many classes where you were trying to figure out how to program just beating your face against the monitor nonstop. Maybe you have, maybe this course will help. So who am I and why should you listen to me? Okay. So first of all, I'm Chuck. I'm an instructor. I'm not a professor. Well, flattering when people call me Professor Chuck. I am not. I am just a graduate student like the rest of you, so don't treat me with any respect. Next, I'm just a 6-year graduate student in sociology. I'm a 6-year grad student, which means I've been here a long time. I do know some things, but I'm on the level of some people taking this class, right? So I'm not sitting, up there's some professor. Hopefully I know what you're going through, and I've structured this class to be more like something grad students can take while taking all their other classes. My own research is generally broadly in quantitative sociology. I do pretty heavy statistical modeling and stuff. I'm not really a big data person, but I do a lot of general quant sociology with advanced statistics. I do some computational social science, things with like social media data, advanced mobility data, digital trace data, that kind of thing. And my sort of core stuff has been experimental criminology. I spent a lot of time doing field experiments in deviance and social control in Seattle for many years, that sort of thing. So to translate that into what that means for you taking my class, I write code every single day. I'm not somebody who teaches this class from the perspective of being a computer scientist who comes at it from a theoretical standpoint. I know the things you actually are going to use in your day-to-day sort of research and work on things. I teach you only the things I use myself that are practical and applicable to general data analysis projects, okay? So I'm coming at this from an applied perspective rather than something theoretical. And that will explain sort of the flow of this course, where we're going to get into fun stuff first, hard, annoying stuff later, rather than starting with some foundation of like flow control and loops, which would not be useful to you immediately. Next, I am a gigantic nerd. And when I say I'm a gigantic nerd, I mean I really enjoy this stuff a lot. I enjoy talking about coding. I enjoy writing code. What this means is when you have problems with what you're doing, do not hesitate to shoot me an email, shoot me a message. I like the problems people bring me, even when they think they're stupid questions. I think they're fun to talk to you about, fun to work through them. It's perfectly fine. I'm a giant nerd, so bother me with this stuff. It is not going to bother me. You are not giving me any trouble. And last, I think programming is incredibly important. So I'm a sociologist, I'm a social scientist, but I use programming every single day, and the coding that I do makes my research better. And I think in general, in the social sciences, well, sciences in general, if you have good foundations in programming skills, it will make your research better, much better. You'll get rid of mistakes that could result in terrible things, which we're going to talk about, I think, mostly in week 3. It can make your research faster, allow you to focus on the actual hard problems. So things like manipulating your data, setting up so you can run models should not be a hard thing that takes you a lot of time. What's hard and takes a lot of time are like research, design, interpreting things, actually doing the writing. Should be focusing on those things, but you need programming skills to bypass the stupid busy work of things like living in an Excel spreadsheet, manually coding and cleaning, things like that. If you've got 5,000 observations in your data set and you're like manually cleaning text entries in all of them, you are wasting valuable hours of your life doing something that can be automated if you learn how to do it in a class like this. Okay. So the logistics of this class. So obviously the location is wherever you happen to be right now or are on Wednesdays or Mondays at 3:30 to 5:20. The Zoom link that you have now is the same Zoom link we will use for every subsequent lecture. You tap in here at 3:25 or so, about when I'll open the room, I will be here. Office hours, I'm not going to be in my office, so they're by appointment. I have a separate Zoom channel specifically for office hours. You let me know, I'll send you the link, we'll meet at a specified time. All course materials, literally everything for this course is on that webpage. And when I say everything, I mean every piece of code that generates all the slides in my class, everything like that is available there. You can download my entire course as a zip file and re-render all the slides, homework assignments, everything in one package. I hide nothing from you. So if you see anything I've done, you can go and take that code. And if you want, use it for your own purposes. My class is open source. You are welcome to use anything for this course in your own research. Okay. So grading in this class is structured to be as minimally threatening as possible and virtually impossible to fail. So it's a credit, no credit class. 60% of the points are necessary to get credit. There's homeworks most weeks. Homeworks are 75% of your grade. Basically, a homework is worth 3 points. There is a peer grading of each homework worth 1 point. So each week there's about 4 points. Both of these are handed in via Canvas. Okay, the Canvas site should be up and active. Somebody has told me that maybe the dates are not current on it. I thought I'd fixed it, but I'll go back and verify those are correct. Won't matter too much. Okay. And of course, like I said before, if you have any kind of questions as I'm going, feel free to press the raise hand button in the participants thing on your little list here, or to type something in group chat. I'll see it, I'll answer your question. Okay, so UG peer grading. I have in the past dropped classes because they involved group projects or peer grading. So I understand people don't probably want to do that. The reason I do it in this class, well, there's a few reasons I do it. First, you will write your reports. And when I say reports, I mean your homework assignments. You will write them better knowing others will see them. And I know this with experimental evidence, because experimenting on my students is one of those things that's fun to do. You will actually produce, on average, better assignments when there's peer grading versus not. Exact same homeworks, people turn in better, more coherent ones when they know somebody else is going to see them. Next, you'll learn alternate approaches to the same problem. People will do wildly different things on the same homework assignment, especially in the first 3 homework assignments. It's nice to see what other people are doing and how they think about it. Then, of course, there's a pragmatic one. I am allowing in basically as many people as want to take this class because it's remote and I can handle many faces on my screen. If I have 60 students in the class, I cannot in detail grade all 60 homeworks once a week through this class. So what I need is each individual person putting their eyes on homework assignments and drawing attention to it. What that allows me to do is, and I do still look at every homework assignment, I just only spend 3 to 5 minutes on each one instead of going through them like with a fine-tooth comb. I can look at people's comments and they'll say something like, oh, this part of it didn't work. I can go focus on that and then maybe give them code that will fix that particular thing. It's just I need those extra eyes. So I'm kind of crowdsourcing this a little bit so I can have as many people in the class as want to take it. Okay, the format for that, homeworks get turned in the Tuesday before lecture each week. The next day on Wednesday, peer reviews will get assigned. You have a full week, so the same period you have to do the next homework, you have to do your peer review. Just by the following Wednesday, get them in. There's a grading rubric on the website. Look at it, take a glance through it. It's pretty straightforward. So what I want is you will leave constructive comments in the Canvas comment box over there. Constructive comments, more than just good job, this looks great. On the first 3 assignments, I expect a few sentences at least. Just say, you know, if everything looks gorgeous, I mean, if it's a truly beautiful homework, tell them that, give them praise, boost their confidence. But if they have little problems that you see, you let them know, you line it out. 3 sentences minimum, some people write a couple paragraphs, that's great. On assignments 4 and later, you'll often have a lot of people with assignments that look very similar because we'll be working on these homeworks together in lab. You'll need less feedback if they did it in lab and it's perfectly fine. It's fine, couple sentences, that'll be good. In any case, if you want more feedback on a homework, email me and I will give you as detailed feedback as you want. I mean, I can go through these things line by line and help you out on them. I do not mind. I'm just not going to do that by default because most people don't need that nor want that, but I will if you ask. Okay. As I said with materials, all the course materials are on the course website, has the slides, the code used to generate them. There's an R script you can use to follow the slides along in class. So if you want to run the code, you're going to see live embedded in these slides, but you want to run it in your R rather than like having to run in my slide code. There's an R script you can download for each week, and it has all the lines of code you'll see in the lecture slides. There's also PDFs for people who need something accessible to take notes on or use with like annotation software. Then there's homework templates, video recording. So this is being recorded right now. I will upload the video of it to YouTube, and it will also be in the Zoom cloud where people can access it. And then there's a bunch of useful links. If you find anything doesn't work on the website, let me know via Slack or email. I'll fix it pretty fast. Okay, so labs. Labs are optional. If you don't want to come to labs, you do not have to. They're strongly recommended though, and they will be recorded this term, which is unusual. Normally I make people come if they want it, but we have people in other countries, like overseas right now due to raging pandemic. So I will record them and share them with people. Okay. So the way labs work is in the first 3 labs, I'll provide what I call like general technical support. I'll answer any R-related questions you have. This also includes questions not related to homework. So if people don't have homework questions and you ask me something about something else, I'm perfectly happy to answer it. Yeah, so the thing is homeworks 1 through 3 are sort of unstructured homeworks, and so it makes sense to provide sort of a general thing. People ask me questions, otherwise you can just sit there and work with my face looming in the background, and if you've got anything for me, you'll let me know. Okay. Okay. Somebody asked me a question here. I don't understand what you meant by an R script for the slides to follow along in class. What is an R script? This is actually a great question, which I have not explained yet. Later in the class this day, actually, I will explain the difference between an R script, a markdown file, and output files for these. So I will get there. The gist of it is that the R script is the actual code you would be writing into your R to run particular commands. It doesn't probably make much sense if you're totally unfamiliar with R to be following along in it right now. By next week, you'll know what I'm talking about because I'll be explaining it here. I'll open one up in a minute to give you an example. Okay. In labs 4+, this is the latter 2/3 of the course, we will walk through homeworks together. So this gives you an option. If you're pretty savvy with this stuff and you don't need any help, don't show up to lab, do it on your own, see how you do. If you're sophisticated enough to feel comfortable doing that, you will learn more by not being guided through it. But I found that maybe half or more of the class prefers a more guided approach. So labs 4+ are going to have a guided approach where what we will do is people will come in and we will work through the template together in sort of a question and response format. I'll ask people, well, what is this asking for? How might we do that? And then we'll kind of prod you through it in the space of a couple hours. Okay. So there is a mailing list for asking questions and getting help. If you use the mailing list, do not ask questions like this. I tried LMYX, but it didn't work. What do? Please do not do that sort of thing. Instead, ask questions like this. Provide a little code that sets it up so people can test what you ran, and then an actual error message. So here they've assigned Y, X, they have a model. It's fine to not know what any of the syntax means. You're going to start learning it today. And then the actual error message. To somebody who's been using R a while, I can look at that error message and immediately know what the problem is. The problem is the Y they created is 10 elements long and the X they created is 11 elements long. It creates an error. They can fix it by changing the 0 to, they can fix it by changing, if you can see, this 0 to a 1 would fix that error. I can see that instantaneously. I have no expectation any of you would see it instantaneously. You send me an error message, I will solve your problem. Do not dwell on them forever. Okay. Yeah. Next, there is a Slack channel. The course uses a Slack channel for general, like, additional communication. I sent you a link already to join that list. If you didn't get it, either because you joined the class late or you just didn't see it, email me directly. I'll send you that link. It's kind of like the mailing list, but it's better for short questions and things which involve a lot of back and forth. So if you've got some small question, it's going to be followed up with another one and another one and another one. Hit me up in the chat channel or other people, and people can weigh in on each other's things. If you have an answer to somebody's one, I haven't gone to it yet, answer their question, chat back and forth. It's a good platform for it. For big questions, shoot me out, hit it on the mailing list. If for some reason, and this is perfectly fine, if you don't want to blast something out to the whole email list, the whole Slack channel, because maybe you're embarrassed, it gives you anxiety to do it, I totally understand. Shoot me an email directly and say in the email also, don't send this out to the chat channel because it makes me feel weird. I will not send it out. I totally respect that privacy. But normally if somebody has a question, other people have the exact same question, so I like to broadcast them out. Okay. So a note on formatting before we get started. In these slides, I try and follow a somewhat uniform format to highlight things for you. Bold usually indicates some important vocabulary term. If you see something bolded, it's something I mean for you to understand what that word is and maybe remember it. If you see a bolded word and I don't explain it and you want to know about it, stop me because I probably was supposed to explain it and let me know. Italics usually indicate emphasis, but they're also pointing out things you need to click with your mouse. For example, I might say, please click File and then Print, say at the top of your window. Code, which is usually has a gray background like that, is in a code looking font, represents R code you might type into your editor or console. We'll talk about what the editor and console are in a minute, or keystrokes used to perform actions. For instance, I might say something like press Control P to open a print dialog to print your screen, which we won't do in this class, but it was a good example. Next, code chunks like this that span the entire page represent actual R code that is embedded inside these slides. When these slides were run, and when running them is called knitting them, which we're going to learn later, there was R code there. It ran the R code and then it puts the output from that code into the slides. So where it says 343 under that 7 times 49, I did not write 343. It took my code above that says 7 times 49, calculated it, and then put into my slides the result of that multiplication. Okay, this is something very powerful we're going to talk about as the class goes on, and all your homeworks are going to be done this way, where you put into a document code you want it to run. It runs that code and outputs it into the document where you can see it. Okay, the lines preceded by the hashtags there, pound signs, represent output to that code. That is the result of running it. We're going to talk a lot about that later. Okay, so the lecture plan for this course. Today is an overview of RStudio and R Markdown. Next week, we jump straight into fun stuff. I don't go into like programming basics. I go right to visualizing data using ggplot because it's fun, powerful, useful, and it shows you it's actually kind of easy to do that stuff. Then we'll get into manipulating and summarizing data, mostly using dplyr. Then understanding our data structures. Week 4 is when I start to get boring, and we're going to talk about things like matrices and data frames and vectors. Then importing, exporting, and cleaning data, which also involves reshaping data, which is useful if you're familiar with wide and long data. It's very important to get your data in the proper format if you want to run statistical analyses. Then using loops. This is sort of a day on fundamental programming. Loops are in every programming language out there that's not a markup language. They're important to know. They're powerful in R, but I don't teach them until week 6 because I actually don't want you using loops unless you have to. Then we're going to talk about writing your own functions. Everything in R that you run sort of as a command is a function. Other people wrote those. There's no reason you don't write your own. Then we're going to talk about specific topics. Working with text data is a big one that gets neglected in other programming classes and is really important if you're in the social sciences. Often we end up with lots of sort of unstructured text data, things like the names of places, names of individuals, countries, that kind of thing. And they often come to us in some terrible format because we work with administrative data. At least I work with administrative data. You need to learn certain special tools and techniques to deal with text data. I'm going to talk about those, which includes regular expressions in week 8. Really important if you work with any categorical data. Then I'm going to talk about working with geographical and geospatial data. This is another special topic that usually gets neglected in other classes. It turns out R is a really nice geographic information systems platform. You can do all sorts of cool mapping, geostatistics, and things in R very easily. It's a cool lecture. Lastly, I'll do a split lecture, which is on reproducible research, just reproducibility, sort of definitions, techniques, approaches, and then working with results from statistical models from all the other CSSS or stats classes you might take, things that they will not teach you that make it really easy to get model results out of those things. Okay. No questions yet? We good? Lots of nods? Nice. Okay, it's funny when you look, it's kind of like having a class. I've got a whole field of nodding heads and things. Okay, every once in a while a child or a dog goes by. Okay, so getting into the actual lecture itself, I'm going to talk about R and RStudio, which is what you are here to learn about. So, why R? R is a programming language built for statistical computing. If you already know something like Stata or some similar software like Minitab or something like that, why would you want to use R? Well, the first one, and often a big one for graduate students, is that R is free. You don't need some terminal server to use R. You download your own R and RStudio to your computer, and you have what everyone else has to work with. You've got all the features you want. Everything is there. It's totally free and will always be free. It's not like Stata, which has a license, or something really expensive like SAS or SPSS. Next, R has a really large community. R has a larger community than any of those software packages I just mentioned, things like Stata, SAS, SPSS. There's more R users than all of those things. The only community out there that's doing a lot of statistics analysis that's larger is Python's, but R probably actually still has a lot more statisticians working in the language than Python does. It's huge. Big communities mean it's really easy to get help and to find resources and to find cutting edge routines. If some new statistical technique comes out in a statistical like journal, it probably gets released as an R package and is already available. If some new visualization technique appears, it was probably either written in R originally or gets ported to R pretty quickly. If you have some question, some error message, if you copy that error message out of your R console, paste it into Google, you will get some Stack Overflow posts where somebody has had the exact same problem, possibly hundreds of people. It's very rare to encounter a unique problem somebody else hasn't seen. Similarly, if you have some task you want to perform in data analysis, you Google it, someone else has had that exact same problem. You probably will never have to do any unique thing in your entire life in R because someone else has solved that problem already. Big communities are nice. Okay. R can handle virtually any data format. So up until last term, I used to have a bet where I said, if anybody could bring me a format of data I could not open in R, I would buy them a beer. Last term, I now owe a Canadian a beer because it turns out the Canadian Statistical Bureau, I think it's just called Stats Canada, Statistics Canada, their archived census files are in a god-awful format that I could not open in R. There's some sort of encrypted SQL database encased in a cube, and I couldn't figure out how to open it. That is the first time in all of the years I've been using R, I have not been able to open a file I encountered in R. That is pretty good. If you want to open something in R, you generally can. And that accounts for any other statistical package, anything out there, any kind of thing in raw text format, R can handle it. Okay, next big one for me, and should be a big one for the sciences, is that R makes replication easy, replication and reproducible research. Most of my journal articles are set up in such a way that with a single button press, it can take the raw data, do all the data manipulation on that raw data, run all the models, extract results from the models, do all my plots, do all my tables, put them inside the paper, and render it as a PDF in that journal's format in one button press. This is very powerful because it means if you need to update something, maybe you found you accidentally excluded 10 cases all the way at the beginning of that process when you did your cleaning data. You are not manually rerunning, copying, pasting, changing every table, redoing every figure by hand. Instead, I would go back, add those 10 observations in, press the same button, and the entire journal article would update. This is really nice. It also means that if somebody else wants to replicate your research or reproduce your research, you can send them the files you have and they can press that one button, see everything that runs and see the results that come out. This is something really nice and that sort of many disciplines are moving toward, is having all the research be maximally reproducible. And there's some journals that are kind of getting to a point where if you don't provide all the things necessary to do that, they're not even going to publish you in the first place. An example of this would be, I believe what is the name of it? The major political science journal, and Science is also making you give reproducible files for everything. So you might as well learn how to do it. Turns out it's pretty easy to do, and it makes your life easier because you're not copying and pasting crap into Word all the time. Somebody asked me the question, how many hours did I spend trying to open that cube file from the Canadian? The answer is I spent an entire day on it, because when I get problems like that, I cannot let them go. I tried multiple times. I tried to put it down and do something else, but I couldn't focus on anything. So I tried. I actually figured out what the format was, and I figured out a way to open it, but I just couldn't use R for it. I had to basically send it out to the big data processing Azure servers for Microsoft. They could crack it open and give me extracts out, but it was a really awkward way to do it. I couldn't do it in R. It took me like 10 hours to do that. So that gives you an idea of how much of a nerd I am and how much I will work on your problems if they're hard to solve. You send me things. This person wasn't even a student of mine. It was a random person from Canada who saw a YouTube video of mine, and I spent 10 hours on his stuff. Send me problems if you've got them. Anyway, then next, R is a language, so it can do everything. Programming languages can do basically everything you want them to do. If your computer can do it, the language can make your computer do that thing. So people can use R for doing things like video and audio editing. I've used it to make animated GIF memes before. You can do just about anything in R. It can interface with everything on your computer, provide packages and things like that. If software can do it, R could do it. R might be slow at doing it, but it can definitely do it. If you master R, you can do anything you want. It's a one-stop shop. Anything you could ever need to do with data, you could basically do in R one way or another. Okay. Another thing, R is a good stepping stone to other languages. If you want to go on and learn something like Python, Python's actually technically a slightly easier language to learn for many things. I would actually argue, having experience with both of them, that it's not as easy for data analysis and data manipulation as people will sometimes tell you. But R is a good stepping stone to those languages. The fundamentals of R apply to other programming languages, especially things like flow control, loops, allocation of things, that kind of stuff. They apply. The things you learn in R and you learn in this class, if R dies, it somehow disappears, which is pretty unlikely because it's actually flourishing right now. But when it does, the skills you learn in basic programming will be applicable in other languages. You are not throwing that stuff away the way you do kind of when you learn specific skills in something like Excel, unless you're learning Visual Basic, Stata, unless you're learning things in Mata a little bit, SAS, SPSS, Minitab, something like that. Those skills, they kind of go with that software. They're specific to it, except basic things like looping that exist in all of them. Okay. Which lecture is the one where we learn to make memes? This is now my most pertinent reason for taking this class. So the visualization one will teach you the background for it, and there's links on animation. And if you put the visualization stuff you'll learn next week with a little bit of GG Animate, it should immediately become apparent to you that you can do things like embed images into them, and you'll be able to figure it out. Okay. Oh yeah, so somebody asked also how to see the questions asked by other students. People are sending me private messages because they're bashful. You can feel free to send them into the global chat, and I'm gonna read them out loud anyway. So that's also why I'm reading them out loud. If you send me a private message, I have to read it out loud to make sure everybody hears it. Okay. Yeah, that's it. Back to the lecture. Okay, so I've told you about R. RStudio is a different thing. RStudio is just a front end, an interface, or what is called an integrated development environment for nerds for R that will make your life easier. It is not R, it's just something that lets you interface and work in R more easily. What RStudio can do for you is it will help you organize your code, your output, your plots. It will help you autocomplete code, and it will highlight syntax. So it will show errors before you have to run the code and things like that. It will color code things for you, help you organize your code nicely. It will also help you view data and objects. A normal R instance is just this little box. It doesn't tell you what data you have loaded, doesn't highlight your syntax, any of that kind of thing. You can't even like type multiple line scripts into it. All that stuff is part of RStudio. It will also help enable easy integration of R code into documents. So the R Markdown documents I talk about, we use throughout this class, are, well, you can use them without RStudio, were really mostly developed by RStudio and are integrated into RStudio very well. Okay, so what I want to do is I want to sell you on R Markdown, which I've talked about a little bit. So these slides you're looking at right now are R Markdown documents. Your homework's going to be R Markdown documents. Secretly, my journal articles are usually R Markdown documents. Okay, so the ability to create Markdown files like this is one of the big, powerful advantages of R. Other software that for statistical analysis and stuff is slowly catching up to R in the ability to generate documents like this. Python for a long time has had IPython notebooks, or Jupyter notebooks they're called now, which are similar to Markdown documents, but a little less flexible and powerful. Stata's most recent version introduced a very primitive version of this as well for integrating analysis into documents. Okay. So what these R Markdown documents are, as I've talked about a couple times, are document analyses that are generated by combining written text, written code syntax, and the output from that all into one document. This allows you to have no more copying and pasting into Word. You don't write your journal article in Word and copy and paste tables and pictures and stuff into it and have to adjust the Word document every time something changes. It's a one-stop shop. It's all in one document, or maybe a few scripts that feed into this RMD document. It's so easy for collaborators to understand. It's easy for your collaborators to understand because you can send them a single document that contains all of the data manipulation, the analytics, and the written materials surrounding it. So they can see how every part of it was done and how the numbers in the text were generated. You hand it to them. If they don't know where something came from, they can run the code literally inside the document and see where everything came from so they can trace it. If you and all your collaborators all are savvy with R, you all work in R, you can basically work on a single document and everything can be self-contained in there. All the data manipulation, analysis, plotting, all the writing, everything. Okay. Nice thing, you can show as little or as much code as you want. When someone sees a journal article that I've written as an R Markdown document I send to them, they don't actually see any code in the document at all. They get a final PDF. It has plots, it has tables in it. The document generated all those things in there, but all the code used to generate it is hidden from them unless I choose to allow them to see it. So it means it can look like any normal journal article, any normal website, whatever you want, but the code is embedded in the document that generates that PDF or that website. Like these slides. These slides have code embedded in it, but you only see the stuff I choose for you to see. There's secret code working in the background as well that's hidden that you could see if you loaded up the RMD file for these slides, which you can feel free to do. It's posted publicly. So R Markdown documents can produce many different document types as output. If you want any kind of document, there's probably an R Markdown format to generate it. Some examples. PDF documents. If you want, a journal actually wants it in PDF format, you can give it to them that way. If you want PDFs because you want to hand them to people, my advisor likes getting PDF memos of things. I render all my memos as PDFs. I hand it to them. You can also produce HTML web pages and reports. In this class, you're going to hand in HTML documents because you don't have to do crazy things like own a PDF editor. You just open them in a browser. It's perfectly nice. They work fine. I'll get to a couple questions here too, and I'll get to them in 1 second. You can also generate Word and PowerPoint documents. And this applies to a question somebody asked here. Somebody said, can you track changes in R Markdown while working on a publication with collaborators? So there's two different ways to track changes, in my opinion. There's more with R Markdown. One way to do it is host your things on a GitHub or Git repository. Whenever you make changes, it will merge those changes. That's technically the best way to do it, and it's the way like software developers do it. If you collaborate with people who use Word and you want to use R, there's a package, that name I forget about at the moment, that actually can digest Word files into Markdown documents, including their comments on them and like track changes stuff, put it into the RMD file. You can make those changes and it will spit it back out as a Word document. So there's some real fancy stuff out there to handle that. Normally with like track changes kind of thing, the best way to do it is to work in a Git platform, which I'm not going to talk about in this class. But if you're interested, I will talk. Actually, wait, no, week 10, I talk about Git a little bit. You could have your own class on that. It's kind of its own thing. Next, you could also generate presentations like these slides. There's many different presentation formats. Mine are kind of fancy. They're built out with some special stuff. Basic slides in RStudio, or rather in R Markdown, look very nice, and you can come out as Beamer PDF slides, IO slides, slidey slides, things like that. Let me get to some more questions here before I continue. Next. Okay. So, could someone build a different GUI for RStudio using RStudio or R? Yeah, you actually could probably build I mean, so essentially, if you think about it in a way, shiny dashboards, which I'll talk about only briefly later, are technically GUIs, and you could make one sophisticated enough to sort of run R inside. So you can run virtual R sessions inside R, nesting dolls. It's theoretically possible. The answer is yes, you can build interfaces and stuff, but typically to do that, you have to interface with lower level stuff on the operating system to generate windows and things. So in that case, you might be kind of building it in R, but you're also really using code that's in other libraries and things. Theoretically possible, not a practical thing to do when it's super easy to build those. So as a side note, RStudio itself, it looks like it's this nice Stata-like piece of software or something. It's actually a web browser window. It's actually just a CSS HTML window that's being displayed. So if you know how to program web pages in CSS, you can write a new front end to like RStudio's GUI there. It's basically just a web browser. Next, can R Markdown files be used in an Adobe Suite product, specifically InDesign? I'm not positive. So you can generate formats like PDF, which is actually a container format. You can generate many different types of formats. So I'm not sure if you can talk back and forth between like an InDesign file. Basically anything designed purely to run with sort of a graphical user interface might be a little wacky to interact with directly with R. So it's a good question. I'd have to look it up. If you're curious about it, shoot me an email. Next. What is the relationship between R Markdown and RStudio? Is R Markdown like Google Suites, whereas RStudio is like Microsoft Office? Not exactly. So R Markdown is a particular format of documents that is used to convert something with embedded R code into other formats using something called pandoc, which is not an R specific thing. R Markdown was developed by people at RStudio, the company, but it is a separate thing and it's open source and its own thing. It's maintained by someone else. RStudio is a piece of software, which is itself in some ways kind of like Google Suites or something like that, or Microsoft Office. It is sort of its own product for doing many things. But I wouldn't say it's exactly like something like Office or Google Suites. How would I put this? It is just an interface for doing these things. You can do everything you learn in this class, including R Markdown documents, without using RStudio. You could do it in something like R Commander. Actually, if you like working in Vim or Emacs and any of those other editors, R Markdown still works in that, so it's not like a proprietary product. RStudio is just the interface I choose to use because most people find it the most user-friendly. Hopefully that answers your question. Follow up if it doesn't. Yeah, somebody said GitHub is an online platform that hosts code for sharing. Yep. Somebody asked, can citation managers and R Markdown work together? I'm glad you asked. They can indeed. So there's a plugin called like Reference Manager for RStudio. I think it might actually be called Citer now, C-I-T-R. And what it will do is allow you to insert citations in an R Markdown document, which will then reference an external BibTeX file like generated by Zotero. And what that does is it will take some short snippet of code you put in the text, automatically populate it with the correct citation. So you might have some little code that goes to like Samson Rodenbush, 1999. It will insert Samson Rodenbush, 1999 in parentheses, and then at the same time generate a bibliography at the end of your document, properly formatted in whatever format you select, like ASA format for my dissertation and stuff like that. So R Markdown can handle all those sorts of things and actually make them easier to use, in my opinion, than the tools in like Word. Okay, is RStudio similar to yes, Visual Studio. RStudio's closest analog really is Visual Studio, and Visual Studio, so Microsoft's sort of integrated development environment, also is what you would use to integrate with Microsoft's version of R, which used to be Revolution Analytics. RStudio is very similar to Visual Studio. Okay. Follow up to R Markdown or RStudio. I'm confused as to one would use one versus the other. So the thing is, you're usually using both at the same time. So RStudio is the interface you're going to use for writing actual code, including Markdown documents. So what you'll do, and I'm going to show this in a little bit, is you'll have your RStudio open, you'll go and create a new file, and one of the types of files you can create is an R Markdown file. RStudio is just the interface you're going to use for writing these things, if that makes sense. Okay. Now I'm gonna hop on. Okay. Chugging along. Okay. You can also insert LaTeX and HTML directly into Markdown documents if you need more formatting control or you want to insert math. We'll talk about that a little bit later. Okay. So to get started in R, finally, what we can do here is, if you have it up, you can open up your RStudio, go to New File, RScript, and I'll show you around. What I'm going to do here is I'm going to drop this. I'm going to pop open my window. You see my RStudio window, everybody? Nods? Dope. Okay, so this is an RStudio window. Yours might look a little bit different. I choose a dark background like this because I spend a lot of time coding and the white background destroys my eyes over time. You can customize that up in tools and settings. Anyway. So the layout of this particular interface, you can see my mouse cursor too? Okay, good. So the layout of RStudio is this. You might not have this window here right now. If it looks like this, you can go up here and click File, New File, and this is where you would say create an R script file. The script files I was talking about before, so you can write R code straight into them. You could also create R Markdown files here, but all sorts of other things. You'll see in RStudio, you can actually write in other programming languages you do too. It's a general IDE like Visual Studio. You can do anything you want in it. I write LaTeX in here. I've written a little bit of C++ in here, that kind of thing. Anyway, we're gonna go here and click R script. It will pop open this. This window that's generated here is what's called the editor window. You can type code you want to run here. So for instance, if I want to type something like, perhaps I want to just, there's data sets built into R. An example of them is the cars data set. I could type cars, and if I run it, the results of this are going to pop up in the console window down here at the bottom. The console window is where whenever you run code in R, the results of it pop up. I could also write code directly into here and run it. The difference between the editor window and the console window is when you run something in the editor window, it doesn't just disappear. Any code you're ever going to run more than once goes in the editor window, and basically all code you write should go into the editor window. The console, you write code here that you're only going to want to run once and ever once. Things that you run once are like installing packages, which I'm going to talk about in a little bit. Most things you want to run in the editor window, but your results will pop out down in the console. In the top right is the global environment. Anything that is loaded into R, data sets, functions, things like that, are going to appear in the global environment. They'll pop up. We'll talk about this a little bit more, and you'll see as you load things in R, they all pop up here. For instance, I could create a new object that contains the number 10,101. If I run this in my global environment, I now see there's an object called new object 10,101. Your environment displays anything you create in R. It's fine to not know what I just did there. We're going to cover that in about 5 minutes. Okay. The last part of RStudio that's important is these windows in the bottom right. These are a help window. If you have questions about how do I run a particular function, you can type the function name, and it displays help files. The newer you are to R, the less useful these help files are because they're written for people who know how to use R. At this point in your career with R, they are gibberish. Most of the time, if you want help, I recommend Googling it or asking me. Over time, you'll learn how to read these R help files. Down here is also going to be, if you generate plots, they'll appear here. There's a file browser that lets you browse around on your computer and open files. There's a viewer for looking at documents, and you can load packages directly here too. We'll cover all these things over time, especially in lab. Okay, go back to the lecture. Here, okay. So, editing and running code in R. There's a lot of different ways you can run your R code in RStudio. The first one, you could highlight lines in the editor window or just have your cursor anywhere on a line. You can click run and it will run that code at the top of your window, or you can hit Control Enter on a Windows machine or Command Enter on a Mac. It will run the line of code you're on. You can rapid fire run lines of code if you want, and you'll get them just running one after another, top to bottom. Next, if you have your caret on a line you want to run, your caret is the little blinking cursor in RStudio. It's called a caret. If you've ever wondered, it's not just a cursor, it's a caret. Put that caret on a line you want to run, hit Control Enter or Control Enter, it runs that particular one. Next, you could type individual lines into the console and press Enter. Like I said before, it'll run them in the console and then discard that code, never to be used again. And then in R Markdown documents, which we're going to open up in a little bit, you can click within a chunk of code, press a green arrow to run the chunk, or you can run inside the chunk using Control Enter, Command Enter, like it was a console or a script editor. Okay. There's also a little button in an R Markdown document I'll point out later that will run every chunk in your document up to the one you're at, which is really good for reloading everything. Okay. So when you run these things, the console will show the lines of code you ran followed by printed output, unless you're in a Markdown document, and then it will show the output right below the chunk, like it's its own little console. You'll be playing with this over time. You can familiarize yourself best by actually playing with it. Okay. So If you start to write some R code in your console or editor or something, and you run it, R might show something that looks like this. It may show, for instance, I did open parenthesis 11 minus 2, and I ran that line. It generates a new line with a plus here. This is R's way of saying, I was expecting a closing parenthesis, so I'm gonna wait for you to finish that. If you then typed a closing parenthesis and then hit enter, it would finish it and run 11 minus 2 and give you 9. But without that closing parenthesis, R is expecting more. So when you see a plus sign in your console and your stuff didn't run, it usually means you are missing a comma, parenthesis, or something like that. Okay, common problem. If you don't know what you were missing and you just want to stop what it's doing, hit escape a few times, it will stop. Okay. So now we can actually start doing some very basic R stuff. So in your console, in your R, if you've got it up, if you type 123 plus 456 plus 789 and hit enter, R, by God, can do math. 123 plus 456 plus 789 is 1,368. One would hope a statistical software package could do arithmetic. It can indeed. I actually, because I usually have an R window open, when I want to do quick math, like I put my bills together and stuff, I usually use R as my calculator. It's just always there. It's a good calculator. Next, the 1 down here in the output. So if you see here, there's a 1 in the output. This indicates the numeric index of the first element on that line. So right now, if I do some math like this, this produces a single piece of output. One number, the sum of these 3 numbers is 1368. This index number here is just saying this is the first element of output. Well, yeah, it's the first element. There's only one element to output. Quite quickly, we're going to see you can have a lot of elements of output, and sometimes it's nice to know which one is problematic. For instance, you might display like 20 lines of output, and you want to know which one has an NA in it. You could see that it's like the number 1 here. Maybe the next line is number 15. That means the first observation on that next line is the 15th observation in whatever thing you just output. We'll play with this in lab and stuff. You'll get a feel for it. Okay. In your blank R document in your editor, if you're following along and you've opened one up, try typing this command, square root 400, and either clicking run or hitting Control Enter or Command Enter. I've now given away what it does because when I see R code, I read out what the function does instead of the text to it, but SQRT 400. Okay, so somebody asked me some troubleshooting. When I typed in 123 plus 456 plus 789 and hit run, it returned a blank. Whenever I put the number in parentheses, I got the result you did. It should just work out, and I will demonstrate. If I go over here and I type into my console 123 456 789, it should just work like that. Did yours not work like that? Did you hit enter or control enter is a good question. Yeah, I just typed 123 plus 456 plus 789, and the spaces also note are not necessary. I just do them there because I like things to be tidy. You'll get the exact same result. Okay, and then the next example I did is I typed square root 400, and I got 20 out, the square root of 400. Yeah. She typed it in the editor, not the console. If I typed it in the editor, 123 plus 456 plus 789, I'd have to hit Control Enter, and then it will appear down in the console. Yeah, it's a little silly. Like down here, you press Enter, but up here, if you press Enter, it just goes to a new line because this is an editor. You'd think you'd have to do Control Enter down here to make it work or something, but it's not how it is. Okay, back to here. So next, we've done that. So square root 400. So what square root is here, SQRT with parentheses, this is a function in R. If you didn't have a good idea what a particular function, say square root, does, you could type $SQRT in the console, and it will pop up a help window on the right, and I'll show you. If I type $SQRT, it pops up in the right over here, a help window. I pick SQRT here because it is a good example of a confusing help file for a very simple thing. So I typed get help on SQRT, but it doesn't show SQRT. Instead, it shows miscellaneous mathematical functions. That is because this help file is shared between square root and absolute value for no particular good reason. Sometimes you're going to get help on a function and it will be a confusing file. Very often for base R functions, that is R functions that have existed for a long time, their help files will be inscrutable, very difficult to understand. That's fine. You'll get used to running those ones, Googling for help. Functions I teach in this class in the tidyverse tend to have more useful help files, but not always. Just know you can go to your help file first for help. If it doesn't help, go to Google. If Google does not help, go to me. Okay. I had another question here. When I start typing in the console or RM, the screen jumps, distorts, and sometimes has black rectangles. Any advice? That is a new one to me. That suggests to me you probably have a video driver problem or some software problem on your computer. Software problems or hardware problems like that are particularly troublesome in our pandemic age when I cannot sit down in front of your computer and try to troubleshoot it myself. What I would highly recommend doing is after this lecture, a computer reboot. And if not that, shoot me an email and I'll see if I can troubleshoot it. So normally that's something odd like a graphics driver problem. I have an idea how to solve that by swapping graphics drivers, but it's something I don't want to get into on the live lecture. Okay, next. Okay, so in R, everything in R is an object. Literally everything in R is an object. Every piece of data, every function, every model, every output of a model is an object in R. So it's important to be able to create objects. In R, we create objects using what is called the assignment operator. The assignment operator is a less than sign followed by a dash, okay? The assignment operator creates objects by taking something on the right side of the operator and putting it inside the thing on the left. So what I'm saying right here is I want to create an object called new.object that is going to be equal to the number 144. So I say new.object, assign to it the number 144. Okay? Operators like this, so this is the assignment operator. Operators are a type of function, but they don't have parentheses in the same way. They just look like symbols and they usually sit between their arguments. Usually those arguments are numbers or objects instead of having them inside parentheses like square root, okay? We can do math with operators. So we already used 1, 2, 3 plus 4, 5, 6 plus 7, 8, 9. Well, plus is the addition operator. It's actually a function. And what that function does is it takes the thing on its left side and adds it to the thing on the right. The assignment operator is similar to that. It takes the thing on the right and puts it inside the thing on the left. It's just like a plus sign. It's nothing fancy. Okay. Good question. When do spaces matter when coding? R is unlike Python in that indentation and spacing don't matter at all. So you space to make things readable to you. Spaces do not matter in R at all. Indent however you want. There's style guides you can follow, and I generally try and follow a cohesive style, but R doesn't care about spaces at all. It ignores them totally. The only time it doesn't ignore them is when spaces are used in an object name, and then the number of spaces actually matters. Great question. Could you go the other way around with the assignment operator? Test it and see. You will find you can indeed. You can go either direction. Some people, every once in a while, you'll see them in the wild. They like to assign left to right because they are feral programmers. No, the normal convention is to go right to left, but you can go either direction. There's also, oddly enough, a bidirectional assignment operator I'm not going to get into, but you can do some weird stuff. Okay. Next. Calling on objects. To call an object just means to use the object to produce whatever it contains. So if I want to get new.object, I could just type new.object, and what pops out is the number 144. I'm just using the name of the object and it displays its contents. Okay, so to be clear about this, new.object, it isn't like, it doesn't exactly contain the number 144. Rather, new.object is the number 144. If you assign something to an object, that name, it just is whatever you've assigned to it. It's like replacing that thing kind of with some representation in text. The word means whatever you put in it. Okay. When you name things in R, and naming something is In programming, it's considered a hard problem. Good names are problematic, especially if you have a lot of different objects. Names in R are pretty flexible. They can contain underscores and periods. About the only major restriction is they cannot begin with numbers, okay? You can begin with letters, just not numbers. I say try to be consistent in naming objects. A really nice thing about RStudio is RStudio has built-in auto-completion of your typing, which gives you an excuse to use longer, more informative names because RStudio will complete writing them for you. This is kind of handy. Later on, when we get to some packages that have specific naming formats, you'll see the real power of autocomplete that allows you to search for functions beginning with names. Anyway, good names save confusion later. You do not want to be working on a data set where you have 500 variables named var1 through var500, because it's very easy to pick variable 475 instead of 476 and publish the wrong paper, okay? Good descriptive variable names are important. Longer names are better if they convey enough information to tell you what things are. One of the first things I do if I get a data set that has generic variable names is immediately rename the entire data set to prevent mistakes. This is a good practice. Name things well. This is something that sucks about some statistical software that limits you to like 7, 9, 10 character long variable names. That is really bad. R, you have a basically arbitrarily long name for objects. I forget what it maxes out at, but it's impractically long. It's like 256 characters or something for object names. Huge. You probably don't need them that big, but if you like assigning to sentences, you do you. Okay. So using objects in R. The object's name, like I said before, represents the information stored in that object. So you can treat the object's name as if it were the values stored inside. So if I take new.object and do +10, I get 154. Because new.object is the number 144. I could put 144 there, but I'd rather put new.object there. Identical result. I could say new.object plus itself, it will be 288. Multiplying it by 2, I could take the square root of new.object. This is just to emphasize new.object is the number 144. Okay? Anything you could use 144 for, we could use new.object. Okay. Another thing we might want to create, so new.object was the number 144. Very often, in fact, most of the time in R, we're going to be working with things that have more than one element to them. They're not a single number, but they're many numbers strung together. An example of that is a vector. A vector, an important data type in R, is a series of elements such as numbers that all have the same type, like numbers or characters. You can create a vector and store it as an object in the same way we just created that prior object. The thing is there's a function for creating vectors. The function C stands for combine or concatenate. I usually would say combine because there's a different concatenate function also. You would use it this way. If I want to create a vector of the numbers 4, 9, 16, 25, and 36, I could say create new.object, which is going to contain or have assigned to it a vector of the numbers 4, 9, 16, 25, and 36. If I then display new.object, we see it contains the numbers 4, 9, 16, 25, 36. Ah, it did what we told it to do. Okay? This is how you create a vector. So the thing you might have noticed is if I name an object the same name as an existing object, new.object, it will just overwrite it. It doesn't prompt a warning. R trusts you to know what you are doing. This is another reason not to use really short and uninformative variable names, because you will overwrite things. If you name everything X or you name everything var1 or new object, you will have a tendency to overwrite those things. Use longer names, you're less likely to accidentally destroy something. Another thing is that you shouldn't value any object you create in R because it might be destroyed at any time. You should instead have code in your scripts and your Markdown files that generates the objects you want to work with. If something happens to them, you have all the code to regenerate it. We'll talk about this extensively throughout this class. Is there an undo button in R? If you mean undo like undestroy an object, no, it is done. The work has happened. It has been destroyed. You shouldn't value objects in R. That was your first mistake. No. What you should instead do is have code that regenerates that object. It's very easy to destroy something. I have my R set up, and I highly advise everyone else to do this. When I close my RStudio window, it wipes everything I have loaded. I reopen up again, I must create everything again from scratch. You actually don't want to have things loaded in R that you care about. If you care about something, save it to disk, okay? I have my journal article set up where I press one button, it renders everything from the raw data, but it never actually needs any of that intervening stuff in the midpoint. I don't need any objects loaded in R. It's much better to do that way. If you have like a R window that you've had open, you've been working for weeks on the same thing, and all the objects up in your environment are important to you, you are one crash away from losing everything you have done. That is really, really bad. I advise, don't do that. Don't worry about your objects. You shouldn't need an undo button because the previous line should regenerate that object or the previous few lines. Okay. Can't you delete the new line of code that destroyed that object? You absolutely can just delete that code. And that's the thing, because you're working in scripts and stuff. If you type a bad line of code, it doesn't matter. If it doesn't work, it doesn't matter. You change the line of code, you try it again. You destroy something, recreate it with the previous things. So you just don't want to be working in the console somewhere where you type a line of code, the code is lost forever, and you keep retyping the same thing over and over again, that sort of thing. To give you an analog, so if you work in something like SPSS and you use the point and click interface, if you go through and you set things up carefully and run that interface and you run like some particular operation, but you made one little mistake in it, how do you feel about going back through that point and click interface and selecting everything over again if it doesn't save it or if your software closes? In R, this isn't a problem because you would have written a code script out, and if it crashes out, it doesn't matter. You just load the script up again, run it, you've got your analysis again. We'll see as it goes on that this is kind of nice. Okay, so vectors in R. You can provide a vector as an argument for most functions in R. So instead of having to give something like square root, a single number, I can give it an arbitrarily large set of numbers. So for instance, I can do square root on new object, and you'll see what it does is it provides the square root once at a time for each element of that vector. I pick perfect squares, 4, 9, 16, 25, 36, so I could run square root on them and get 2, 3, 4, 5, 6. So square root basically runs down that vector one element at a time, gives you the square roots of them, okay? This is a vectorized command that runs over as many elements as you give it. If I'd given it a vector of length 10 million, it would have done the square root for all 10 million elements of it. Perfectly fine. Arbitrary lengths, it can just handle them all. Most things in R are like that, so it's nice to give them multiple values at once so you don't have to keep doing an operation repetitively. Just make it do all the work for you in the background. Okay, here's a good one. New object. You have capitalized your C, Alexander. So this is actually an important thing. R is a case-sensitive language. A capital C is not the same as a lowercase c. It cares about these things. It will work perfectly fine if you do underscore. Next one. NANs produce square root new object. If you type new.object in your console and run it, what pops out? Because your new.object must be something different. Okay, in the middle, should the type of elements inside a vector be the same? Can you have strings next to numbers? That is an excellent and sophisticated question. Let's see what happens when we do it. If I take a vector that is the number 11, the word weasel, and a true, what pops out? We get 11, weasel, and true, but notice they are in quotes. What R does is if you give it multiple types of data in a vector, it will make that vector whatever is the simplest data type it can produce without losing any information. In this case, the word weasel cannot be converted to a number, and it cannot be converted to a logical, that is true or false. So 11 and true get turned into character data that is words. If I remove weasel here and run it again, we will get 11 and the number 1, because 11 is a number, but this is a logical. If you convert a logical true to a number, it becomes the number 1, and false becomes the number 0. This is R's behavior. It coerces things into the simplest data type without asking you, okay? Many languages do not do this. They're particular because they're for actual software development. Statisticians are like, let's fudge these things in the background. Okay, so again, that question was, I got NANs. Did you manage to work that out? So if you just type new.object in your console, you should see, and if it has something like the numbers are in quotes or something, that's probably your problem. Okay, I'm gonna continue on. If you have no problem, let me know or raise your hand and I can voice back and forth. Okay, so continuing on. More complex objects. So the principles I've shown you for generating vectors and single numbers are the same principles for generating more complex objects. Things like matrices, arrays, lists, and data frames. Data frames are a type of list that look like matrices. A data frame is basically a spreadsheet. When you load data in R to work all your statistical routines and things like that, they're basically always going to be data frames, okay? So we're gonna spend a lot of time in this class working with data frames. They work kind of like vectors for assigning things, but they're actually composed of many vectors where each vector is a column in the data frame. Okay. Yeah, so before we get into these data types, I want to go back to R Markdown to give you the foundational stuff to produce your first homework assignment. Okay, so R Markdown. So let's try making an R Markdown file. To generate an R Markdown file, you can go to your RStudio, which I'll do in a second to demonstrate. You can choose File, New File, R Markdown. I'm going to show you. If I go to RStudio, I can say New File, R Markdown, and then I'm going to say I want to create just a normal document. The default output format is going to be HTML. I'm just going to leave it untitled as an example here. Generate this document. And then by default, it's going to populate it with a whole bunch of information here. This is sort of a template it gives you to give you some instructions on how to use your R Markdown document. This is actually useful information. The first time you kind of generate one of these yourself, read it to see what it does. Right now, what I want to do though, is I just want to save this somewhere. So I'm going to say, I want to knit this. It's going to bring up a window to say, where do you want to save this thing? I'm just going to save it as an example to my documents. I'm going to say test doc. Now I said knit. What knit does is knit takes this R Markdown document that looks like this and converts it into beautiful HTML documents. This is the essence of the reproducible research tools I was talking about. You will write code in an R Markdown document back here, but that R Markdown document gets knit into an HTML or PDF or some other format, something that's consumable by another person or displayed as a web page. For instance, my entire class web page is a series of R Markdown documents like this. My web page, the whole class was written as R Markdown documents. It's all done that way. My curriculum vitae, it's an R Markdown document. My journal articles, they're R Markdown documents. Most of my life is an R Markdown document at this point. Okay. So what we saw here is that we have this R Markdown document here that has, for instance, a title, an author, a date, some specified output, and then a bunch of code chunks. So this is a code chunk here. This is a code chunk here. And then it has text. This text that's here between the code chunks is just going to get turned into text in the final document. Where the magic happens in these Markdown documents is inside these chunks. So this R summary cars, I could hit Control Enter, and it will give me a summary of the cars data set. The cars data set is built into R, so just know you can call on it and use it. This output that I do Control Enter and I show in this Markdown is what's going to appear in that Markdown document when I knit it. Same thing down here, I could say plot pressure, another data set built into R, and it will generate a plot. If I go back to this R Markdown document, you'll see the output we just saw in that R Markdown is this exact output and this exact plot. You'll note on the second one, though, there isn't any code shown here, right? Okay, but there is code here. This is because I've used this option, echo equals false. It hides the code chunks. So for instance, when you write a journal article in this format, if you set echo equals false to all these things in knit, no one even knows there was any R code in the document at all, but it still generated the document using that R code. This is the magic. You could have an entire project's worth of code inside one of these documents, and it would render out, and people would only ever see the output you want them to see. This is very powerful. Okay. Okay, no questions? Great. I'm gonna go here. Okay, I'm gonna move on. Oh, and here's something good to know. When you bring your RStudio, when you knit, will open this window like this. If you want to view it in your web browser, you can click open in browser and it'll open it in whatever your system's web browser is. These viewer documents here are just a web page, so you can open them in any browser, do anything you want with them. Okay. Do you have to type echo equals false in every code chunk? No, that is also a great question. So if I go to our studio, oh, where is it? Our studio here, you could set, for instance, up here, this says knitter options chunk set echo equals true. If I change this to be echo equals false, it would make it so every other chunk in the document is automatically set to echo equals false and hides it. So you can do permanent settings up at the top. If I then go down here and set this to true, it will override it just for that one chunk. That's a little bit more advanced, and that's the kind of thing I normally do in lab, but it's a great question. So you can set the whole ones that way. I very often have defaults up here set for the whole document to hide all my code. Great question. Okay, moving on. Okay, R Markdown headers. You saw up at the top of that document, there was this header that said like the author, the title, the date. The header of Markdown documents is something called a YAML header, a YAML markup language code header. This is something, it's another language it's written in just for specifying how titles, authors, and things come out of these documents. You don't have to worry too much about it because most of the time you don't really have to manually modify them, but just know it's a YAML header. If you need to Google out like you messed it up somehow, Google YAML header Markdown document, you'll get information. Okay, so you can use these YAML headers to mess with the global formatting in the document. Maybe you want to use a different theme, like there's themes and templates for Markdown documents. You can do things like add a table of contents and things to the top. You can make them interactive. You can do that by messing with the YAML header at the top. Like for instance, adding lines, output, HTML document, theme readable. If I do this and go back to my document I have over here and knit, now it has a slightly different theme. You see how the format, it's in a different font. The layout looks a little bit different. Font's a little different. There's themes. There's a ton of themes built in. You can also make your own themes. I basically have my own themes written for my Markdown documents. You can also get like LaTeX templates from journals to produce articles that look the way the format they like. Okay. Okay. So moving on. R Markdown syntax. So a nice thing with R Markdown is it has some formatting capabilities. The thing on the left is going to be the output you would see in that document after knitting. The thing on the right side is the code you would type in your R Markdown document to get it. So if you take like 2 asterisks around something, it makes bold text. A single asterisk around something makes it an italic. If you put a pound sign before it, it makes big header text. 2 pound signs is a subheader, 3 is sub, and they go all the way down to like 5. If you want block quotes, just put like a greater than sign ahead of some text. It will make a little block quote like this in your document. So you can do sort of basic formatting in these things. And if you use like a template or generate a PDF document, those will be properly converted in a PDF, say to headers, block quotes, bold and italic for you. So you have to go and manually modify those things. You can also do things like ordered lists, and you can even be lazy about it. If you want an ordered list of items, you literally can just say 1 period and then all the items, and it will automatically figure out how to number them for you, or you can put the numbers in yourself. You can also do bullet points like this, and you'll get nice ordered lists and sublists. You can embed URLs in your documents if you want people to be able to click on something as a link. You can embed images, it's just exclamation point and then a URL after it. You can embed things in your documents. Feel free to play with it. So spacing doesn't matter in R, but it does matter in R markup. This is another question. So spacing mostly matters in R markup because it's sort of typing raw text. But R Markdown has a tendency to discard multiple spaces just because it sees them as redundant. Play with it and see what happens. Spacing doesn't matter so much in R Markdown, but R Markdown is basically typing in a Word document. So it's for making it look the way you want it to. In the code chunk, spaces still don't matter because that's just R. Okay, next. You can also do fancy stuff up in your R Markdown documents, like embed statistical formulae into your documents. If you're in a CSSS class and they want things like show the model in your paper, write the LaTeX directly in it, it'll render it for you. No more messing with Word's crappy like equation generator, just type in a little LaTeX code. LaTeX is a terrible language that no one in this day and age should learn, except for learning how to do basic mathematical formulae like this. If you want to know how to do it, ask me more questions about it later in lab, or you can look it up. So for example, if I wanted this equation here, y equals 2/3 squared, I just have this code right here, which says, I forget what the slash left is for here. Y equals slash left fraction. I actually know what the left is. I guess that's an equal. slash left. Oh, duh, slash left parenthesis slash right parenthesis. Never mind. Can't read my own LaTeX. Anyway, this is just generating a fraction. So you have a big parenthesis here, fraction 2/3, exponential 2, okay? It's okay if this doesn't make any sense, but if you want to do these formulae like this in your papers, it's worth knowing how to do it. You can get pretty crazy, like here's a formula for the mean done up in LaTeX, embedded right into this document. You can put this stuff in. I do it all the time because people like seeing the equations in there nice in papers and stuff, but don't have to do it. You can also produce like code-looking font like I do in these slides. It's just backticks here. So this is something important. Backticks. The backtick character sits below your escape key on your computer next to the 1 where the tilde is. Backticks are very important in R. They're used for a lot of different things, but they're often confused with quote marks. They are not quote marks and they work very differently. So familiarize yourself with that backtick key. Okay, you can also put blocks of code in using a series of backticks and stuff in between them, and it will generate a code block. Okay, these are some links if you want to know more about modifying document appearance, formatting your documents. There's also a free online textbook. It is also a print book. It's very good, which is the definitive guide to R Markdown. Oh, here's a question I just got. Do these go in the gray coding boxes or in the white sections of the Markdown file? All that stuff goes in the white sections of the Markdown file. So for instance, if I wanted to put a formula in here, I would just put it, you know, something like y equals x here. And you can see it automatically pops it up, showing what it's going to do. If I knit this, I actually got angry at me about the space. Now I have, oh yeah, it got angry at me about the space. What did I just say? There we go. Nicely formatted y equals x. So you put this outside of the chunks. Chunks are just for writing R code in these documents. Literally everything else goes outside of them. Okay, great questions. Next. Formatting caveats, yeah. R Markdown is pretty simple. It doesn't do really sophisticated things. If you need weird pagination, multiple columns and stuff like that, it gets a little fishy in R Markdown. So you can do things like use other templates, use HTML with cascading style sheets, which is what my slides are. You can also use LaTeX with R and W files and stuff. I will say, in this day and age, do not learn LaTeX. That language will destroy your life. I am quite LaTeX savvy. I spent a large amount of my time on it. I regret everything. But if you have LaTeX questions in the future, I went through that trauma, so I can answer your questions and reduce your future trauma. Okay. For most uses, plain vanilla Markdown does the job. For fancier stuff later, you might have to go into more complex things. Okay. Next, R code and R Markdown. Like I said before, inside R Markdown, lines of R code go in these things called chunks. A chunk is just 3 backticks, squiggly brackets with an R in it, and then some R code here. You can dress up these things and add additional options like I showed with echo equals false and stuff, but a basic R chunk basically looks like this. Some backticks, some piece of R code, and something here. This chunk of code right here embedded in this document produces the output below. If I say summary cars in here, in the output document, it will show summary cars and then the output from running summary cars. That is a chunk. They don't really do anything magical. They just run the R code when you press knit and embed the output that would normally go into the console into the document. Okay. So there's a lot of options you can put on chunks like what I showed before. I showed echo equals false, which keeps the R code from being shown in the document. There's also eval equals false. This will show the code, but won't run the code, so there'll be no output. There's include equals false. Include equals false hides everything produced by that chunk, but still writes the code. When you load packages, which we're going to talk about later, you will usually do include equals false in the chunk you load your packages to suppress error messages, warning messages, all kinds of stuff like that. There's also some other things like results equals hide, which would hide every piece of output except plots. If you have some chunk in your document that takes a really long time to run, maybe you've got some Markov chain Monte Carlo model or something running, cache equals true will save the results, and as long as you don't change the content, it won't rerun it. It will instead load it from a local cache to save you time. I do this a lot because I do a lot of missing data imputation and structural equation models, which are computationally intensive problems, take hours to run. I cache those things so I don't have to rerun them every time. You can also do things like modify the size of plots, the DPI, all kinds of stuff like that. There's a lot of chunk options. There's hundreds of chunk options. So if you want to know how to do something, it's probably out there. If you get lost looking at how to do something, shoot me an email. I probably know how to do it. Okay. So playing with options in this R&D file you have, or in your homework that's going to be coming up, I recommend playing with these chunk options and see what they do. The best way to figure out how anything works in R is to just bash your face against it and see what happens. Mess with it, figure it out, learn what you want to do. Okay. One nice little feature though, if you write your chunk like this, I said R space, this is this place where spaces matter, R space summarize cars. What this does is it makes an R chunk with a title. R chunks with titles are browsable inside your R Markdown document. If I go back to my R Markdown here, see this one is named R Setup and this one is named R Cars. Down here, I can say, I want to browse between the named chunks, and it also has, see R Markdown here? That's the headers you put in the document. If you organize your document using these pound signs and headers and chunk names, you get a browsable menu down here at the bottom that will allow you to move between sections of your R Markdown document. Kind of handy for big documents. Most of the time you won't need to use it. I'll let you know about it because it's kind of cool. Okay, moving on. So inline R code. Sometimes what you want to do is not have some output pop out after a chunk is run, but instead you want the code to appear right in the text of the document. Maybe you don't want people to even know that some calculation in your document was calculated on the fly. I do this a lot in journal articles, like summary statistics. I'll say the mean of this variable and this is this. I didn't write the number in there. R calculates it and inserts it into the paragraph for me when the document is knit. No one knows, but that's what's happening behind the scenes. You can do this really simply in your text like this. I could say something like, write this code in my R Markdown document. 7 years ago is the same as backtick R space 4 times 20 plus 7 years. When then my document is knit, the actual text you're going to see is 7 years ago is the same as 87 years. It runs the math and inputs the text, and people never know any code was run at all. This is an inline R Markdown thing. I'm going to require a couple of these in the homework. Play with them, do whatever you want. Okay. Maybe you've done something like saved a variable in a chunk and you want to reference it in the text. Maybe, for instance, I've made x equal to the square root of 77. But what I want in the text is the value of x rounded to the nearest 2 decimals is take x, round it to 2 decimal places. So this says take x, round it to 2 decimal places, and input it in the text. So we get the value of x rounded to the nearest 2 decimals is 8.77. So you can actually make function calls inside the paragraphs of your document. It works fine. No one will ever know it's there. Pretty powerful when you do things like reference numbers that your data like generated. You've got some long article, for instance, estimates with confidence intervals. You never have to manually input one of those ever again in a journal article or something. You just reference them directly from the code. It inputs them. If you change your models, it doesn't matter. It updates in the text automatically. Pretty neat. Okay. So this is amazing. I think it's amazing. I'm a giant nerd. I think lots of things are amazing, but I think this one is generally amazing to most people. So having your R dump values into your document protects you from lots of silly mistakes. You never wonder, how did I come up with some particular quantity? You just look at the formula in your RMD file. You can see exactly where it's coming from. If it's problematic, it's wrong, fix the code, right? It's not like going to a Word document and you're like, oh God, where did I get 8.77? I can't replicate my own analyses. That's bad, right? There's also consistency. You don't have to find and replace that number every time you use it somewhere in the document. If you just reference that variable, reuse that variable over time, like repeatedly in the document. You don't have to manually update it because it gets updated when the code gets run. For instance, reporting sample sizes. You might mention it a bunch of times. You just create that object once and reference the object throughout the document. Another thing, you're way more likely to make typos, especially in numbers that are hard-coded than things pulled from a calculation. Typos in R usually are going to produce an error message. A typo in your number could just go all the way through an article. I had a non-hard-coded, like an article where I hard-coded some numbers instead of pulling them from R. It got published, and I saw like 7-8 months later that I had a numerical typo like that in the article. It was deeply embarrassing to me. It happens. Don't do that. Okay, here's an example of something you might want to do that I actually use. Can you show us doing the R blah thing in real time? So I was just asked on a private chat, can you show us doing the backtick R space blah thing in real time? I will do this live. Okay, so for instance, I might want to say something like, oh, let's get, Control-Alt-I will insert an R Markdown chunk into your document so you don't have to type all those backticks. Anyway, I'm going to do something like, let's take the mean of cars speed, cars mean. I'm going to assign it to this object here, and then I'm going to say, okay, that is I've created cars mean here. I'm going to go use cars mean inside this R Markdown inline, knit my document. If I scroll down to the bottom, now I have the mean of the speed variable in cars is 15.4. Did my calculation, embedded in the document. Yeah, thanks for typing that in chat. Control-Alt-I, and the Mac equivalent, I can't remember if it's Command-Alt-I. I'm not positive, or Command, it's not Alt, what is it? Mac person will figure it out. Okay. Anyway, so here's another example of an inline sort of thing you can do. Up in the YAML header, you could embed R code in there. This is something I use in my actual, my code for these lecture slides to say when my document was updated. You could say, and I'm going to just copy it right here. If I copy this and replace my YAML header in my document, so instead of manually typing 4/1/2020, I'm now going to say, I want to take the current system date. And you're like, sys.date, what does that do? Copy this into the console. It produces this, 2020-04-01. It's the year, the month, the day. And I say, reformat it in this particular format. Don't worry about what these things mean. We'll talk about this a little bit later. I want my date automatically generated. If I knit this document, up at the top, it's going to say April 1st, 2020. It converted those numeric dates into the word April 01/2020. So if you see on my slides, the very first slide says the last time the slide was updated. It's actually this exact snippet of code is embedded in the first page of every one of my slides. So sometimes these things are useful. Okay. Okay, here's a question somebody just gave me. Should the HTML file automatically pop up when we type in the RMD file? So far I'm not seeing the code. To get the HTML file to pop up, so the HTML file actually doesn't exist until you press this knit button up here at the top. Where it says knit here, if I click knit, what this does is it actually creates that HTML file and then it should open it up. If it doesn't open it up, it probably still created it, but it's in that folder. There's an option you can select to have it not pop these up, which might be turned on. Does that work for you? Let me know. Okay. Keep chugging. Only got about 20 minutes left. I'm going to try and keep you to time. Okay. Next, I want to get in and talk about data frames, because data frames are sort of the basic object you're usually going to work with in R. It's how you're going to store most of your data. Okay. So what's up with the cars data set? I've used cars for a couple of times. In the sample R Markdown document you're working on, we could load the built-in data cars. I did already in that document. You could do it yourself. Cars is a data frame. It contains 2 columns. I think it's like the speed and weight. We're going to see it in a second. We could look at this a couple different ways. I could do something like, oh, first of all, this is a useful function. So you'll notice here, I've been doing the stuff with the cars data set, but there isn't even a cars object shown here in the global environment. Cars exists, but you can't see it loaded. If you want to see the data set you're working with and it's a data set built into R, you can say data cars. Now, do you see something funny about that thing up in global environment? This thing says new object is the number 10,101. Cars mean is 15.4. Cars is something that says a promise. Okay. This is R saying, I promise you cars exists, but I am too lazy to load it until you want to use that object. As soon as I start typing in the console cars, watch the environment pane. It immediately populated. I didn't even get a chance to use it. R uses something called lazy evaluation, which means it tries not to load things into memory until it is pretty sure you're going to use them. In that case, I loaded the data cars, but it didn't actually load it into memory until I started to ask for it. Promise means I promise you it's there, but I'm not going to load it because I'm lazy. Okay. So you could pop up a viewer pane. So R has a built-in viewer that looks like status viewer. If I go back to here and I say view cars, view is an example of a command you do not put in an R Markdown document because you can't pop open a viewer pane in somebody else's document that they're looking at. So use view in the console. Viewer will pop open a new window in RStudio that shows you all of your data. Rows are observations, columns are columns in the data. It's kind of like status viewer and other data viewers like an SPSS. Okay. So other things we might do, the head command in R will show you the first 5 elements of any object you give to it. If I say head cars 5, it will show the first 5 rows of the data frame. So for instance, this is row 1 through 5, column speed, column distance. I could give other numbers to this. I could say head cars 10. There's the first 10 observations. If I just say head, it gets the first 6 by default. A lot of functions in R, you can give them additional arguments to do fancy stuff. If you don't, they have defaults like head does. Normally, when I load a new data set, one of the first things I do is I do head, and then I do tail. Tail gives you the end of the data set. If you load data in and the beginning and the end of it both look correct, the middle probably loaded okay. Okay. Next. Maybe we want to know a little bit more about cars. There's a useful function in R called str for structure that gives you the structure of an object. Structure is really good if you have some data frame that has like a lot of observations or a lot of columns that make it hard to display nicely with head. str on cars will display the object saying, for instance, cars is a data frame. It is a data frame with 50 observations and 2 variables. And then it will show the variables, speed and dist, say they are numeric variables, and then show the first so many observations or elements of those variables. Okay, so structure kind of gives you a brief overview of some object you give it. Simple, useful function. Here's a great question. Is there a reason why you would capitalize view cars? Is there a rule or circumstance when commands are capitalized? R is a capricious god. No, sometimes things are capitalized and some things are not capitalized. In general, modern R functions are almost never capitalized. Older ones sometimes are arbitrarily capitalized. You basically just remember, but most modern R functions have no capital characters because people think it's dumb. Mostly you just know. Usually capitalization is kind of obvious though. So if you try the lowercase one doesn't work, capitalize it and see if it works. Guess and check is good in this case. But yeah, it's arbitrary. Good standards nowadays are don't use capital letters. Okay. Another useful function is summary. Summary will give different output depending on the type of object you give it. If you give a data frame to summary, what it will do is it will calculate means, medians, and quintiles for our, all of your variables in the data frame. So there's 2 variables in cars. Speed, distance, it gives you a minimum, first quartile, median, mean, third quartile, and maximum for each one of them. If you have categorical variables, it will give you some little kind of tallying information. Summary does different things with different objects though. If you run a linear regression model, you run summary on it, it does like a coefficient output with stars for significance and all that kind of stuff. You never know what you're gonna get with summary. Okay, might wanna draw some ugly pictures of cars. The hist function generates a histogram of a numeric vector. So if you want to access a vector that is a column inside of a data frame, you can use $, which is known as the extraction operator. I'm going to say here, I want to do a histogram of a variable in the cars data set. I'm going to extract the speed variable. So this says histogram of speed in the cars data set. I get a histogram of the speed variable. Likewise, I get a histogram over here of the distance variable, okay? So $, here accesses sub-elements of an object. We're actually gonna not use $, that much in this class starting next week because I'm gonna show you other ways to subset, but know in base R, this is how you'd access a variable inside of a data set, Next. Okay, might want to draw some slightly less ugly pictures. So I take that histogram, and all I'm going to do here, I'm still going to do a histogram of cars data set distance variable, but now I'm going to say I want an X label, which is distance in feet, and a main title of observed stopping distance of cars. You'll see down here in the plot, it's the same plot as before, but now the X-axis says distance in feet, and the main title is observed stopping distance of cars. This is an example of taking a function like histogram and giving it a few extra arguments, for instance, to make a nicer looking plot, okay? In this class, we're not really going to use these base R plotting functions very much because they're kind of primitive, but you can use them for stuff, especially like histograms. They're pretty easy. Okay. So we can do some math with cars. Oh, this is a kind of a handy thing. If you take some kind of operation like an assignment and you put it inside parentheses in R, it will do that assignment and also print it to the console at the same time. This is something you might want to do in R Markdown documents if you want to do an assignment, but you also want to see the result of it at the same time. Just as a heads up, it's a thing you can do. Anyway, I'm doing here, I'm calculating, I want the mean of the distance variable. I add it to an object called distance mean. I want the mean of the speed variable, so I add it to speed mean. The means are 42.98 and 15.4. I'm going to use them in a plot in a second. What I'm going to do here is I'm going to say, now I want to create a scatter plot. The base R way to do a scatter plot is just plot. Okay? I'm going to say, I want to plot a plot of distance by speed. So this is going to be distance on the y-axis, speed on the x-axis. This right here is a thing called a formula in R. For a little bit more information, you can see the box down in the bottom right. Basically, y is on the left, x is on the right. Okay. The data it's going to get these variables from is cars. So now it knows to go look in the cars data set and find distance and speed variables. So I didn't have to do the dollar signs. Okay. I'm going to give it a x label, a y label, a main title. PCH16 makes the dots a particular size. You're going to see a lot of me being very particular about things in this class to give examples. So this generates the scatter plot. Now I'm going to add to it a couple lines. AB line draws a straight line. I say I want an AB line that is horizontal and sitting at the mean of distance. It is fire brick red. It makes this line right here. That is the mean of the distance variable. And then another line at the mean of speed in cornflower blue. And it sits here like this. This is just an example of how you can layer plots on top of each other. You can add elements to them. If you wanted this to show up nicely in your console, you'd have to run all these lines at the same time, but you could do that. Okay, I'm gonna move on because we're not gonna spend a lot of time with base R plots. Somebody asked, how do you skip to the next line when you're typing code? Return. So if I go back here to my RStudio editor, if I'm in like my script editor or something, enter will just go to next lines. In your console, you cannot skip to other lines. You're stuck with whatever you're working with. You can paste multiple lines in, like for instance, I could do something like this. It will run all of them, but I can't go line by line, type multiple lines in the console. You should be typing multiple lines up here in the editor window. Okay, moving on. So Swiss, is dist mean a function or did I calculate it beforehand? I did indeed calculate it beforehand on the previous slide. So here dist mean right here is just the mean of distance. I assigned it to that object on the previous slide and I used it in this next slide. So my slides are kind of like a script that builds everything I do in the previous slide works for the next slide too, because it's just a big R Markdown document. Okay, next. Swiss is another data frame built into R, okay? If you do question mark Swiss, and you want to, because Swiss is the data set you're going to use for your homework, question mark Swiss will tell you what all the variables in the data set mean, so you can say something useful about them when you do your homework. Then you could load the data using data Swiss, like we did with data cars. And then you might do something like add chunks to a Markdown document, inspect Swiss, experiment with things. I'm going to go for this kind of fast because I only got about 7 minutes. Actually, we're almost done. Okay, here's an example of a plot you might have in your homework. Pairs creates pairwise scatter plots of every variable in a data set. So what this says here is, give me pairs of the Swiss data set. I want the dots to be size 8. I want the color to be violet because I just felt like making the dots violet. And the title is going to be main pairwise comparisons of Swiss variables. So you see that is pairwise comparisons of Swiss variables. What this does automatically is generate one scatter plot for every combination of variables. To give you an example of what this is to interpret it, if you see here, this plot I'm kind of waving over with my mouse is a scatter plot of fertility and agriculture, where agriculture is on the x-axis and fertility is on the y-axis. Basically, you can look at any one of these plots, look over to the left side, that's the y-axis variable, the x-axis variable is down below it, and this shows a bivariate scatter plot of those two variables. For small data sets, pairs plots are a really good sort of simple diagnostic plot to just get a glimpse at your data. If you have thousands of data points, this will be useless because they will plot on top of each other. But for something like this Swiss data set, they're pretty informative because you can immediately see some things that have obvious strong relationships. Like look at agriculture and examination scores. That is a pretty nice, like downward trending line. Some of these things are kind of weird or nothing going on, like this, like what's going on right here. It's some weird arc with nothing in the middle. This one right here, who knows what's going on, right? But this is a nice diagnostic plot for small data sets. Next. So another thing you might want to do in R, the true power of R as a platform comes from packages or what are called libraries. Libraries or packages are R code written by other people to do functions that aren't built into R. Everything we're going to learn in this class are actually add-on libraries to R. All the real power comes from these add-on libraries. Okay. Something we're going to do for your homework, for instance, is we're going to install and use a package called Pander to produce prettier tables in our R Markdown documents so they don't look like raw console output. To do this, we need to install it because Pander doesn't come with R. So in your console, and this is important, when you install packages, always do it in the console. Never put install.packages in a script, never put it in an R Markdown document. If you put install.packages in an R Markdown document, it won't knit. It will just fail entirely. It's a protective feature. You don't want to force people to install things. Let them install them themselves. Put your install.packages in the console. Another reason for this is every version of R, you basically only need to install a package once. So you don't want to be running it over and over and over again and downloading stuff. Okay, so what you can do is you can take this install.packages Pander. If I go here and say, run over to here, I could say install.packages Pander. What it's going to do is it is going to go to the central R archive network, search for something named Pander, download a zip file, and install it into R for us. Now we have the package called Pander. If I want to use Pander, I have to, and this is something you have to do every script or every R Markdown file where you want to use it, you need to load the library. I can say up here, for instance, library Pander. Once I've loaded that library using library, I can call on commands that exist inside of it. And I'll show you what those are. Yep, like I just said, library, you need to load packages with. You'll notice that when I did install packages, I did Pander in quotes, but when I did library, I didn't quote it. When you install packages, you're actually giving it a search term. It has to be in quotes. When you load the library, you can put it in quotes or not. It doesn't matter. It's an object that exists in R. Okay. So this is what Pander does. I've loaded up the Pander library. Now I've done a summary of the Swiss data, but I've put it inside a Pander call. What Pander does is it formats the tables. Instead of looking like raw R output, now I have this nice web pagey looking HTML table. It formats things a little bit pretty for us. All I had to do was say, put this R object. So summary Swiss is just, right, if I go back to here and I type summary Swiss, it's this table right here. Well, if I go back to my slides, it's the exact same information, variable names and everything. All it's done is formatted it slightly nicely for this, okay? I've added a couple options. I said style R Markdown, which makes it look the particular way it does. And split tables 120 says make it up to 120 characters wide. That's all that is. You don't need those there, but I've put them there. One thing I will note is if you write an R Markdown document and use Pander, you will not have alternating colored rows like this in mine. This is a question I got last term. This is actually because of the style sheet I have that generates my slides. It makes alternating colors. I'm sad. You will be disappointed. Yours does not do alternating colors by default. Okay. So Tables look a little bit nicer this way. You could put anything you want in here, like head Swiss, first 5 observations of the Swiss data set. Pander, now you get a nicer looking table like this, okay? So the thing I'm gonna ask for in your homeworks, don't do raw output tables, do these Pander tables just to experiment with making your output look nice. Okay, so your homework for due Tuesday, I just want you to write up an RMD file. So you'll create a new RMD file and do some exploratory analyses of this Swiss fertility data. That's the Swiss data set, okay? On Canvas, you need to upload both the .rmd file you write your code in and the .html file that is produced when you knit it. The HTML file pops out in the same folder the RMD is in. I recommend that you have like one folder for each homework assignment or something like that, an RMD file in there, you knit it, the HTML will appear in the exact same folder, okay? I want you to mix inline R calculations, tables, R output, and plots with some very light text describing relationships you see. It's perfectly fine to say, it looks like agriculture goes down when examination goes up or something like that. Don't have to, you're not demographers, some of you probably are, but don't have to be too specific about it. All I ask is that you include at least one plot and one table. Go crazy if you want to do more. You can please use at least a couple or 1 or 2 inline R calculations / references, so that inline R code I showed you, and try and use some new function like nrow, mean, SD, core, median. You can play with these functions I've listed here. Main thing, don't hard code any numbers you reference in your text. If you have something in a sentence you use, have it pulled out of using R code. Document should be relatively pleasant for a peer to look at, some kind of organization using sections or lists. You don't have to go crazy, but just try and make it look okay. Try chunk options like echo or results to hide or show things. Summarize specific values with sentences in your text. Don't do like really long decimals. Try and round outputs. You only have 2 or 3 decimal places. It's about all I ask for. So grading rubric for this is basically, you get a 0 if you don't turn anything in. Imagine that. You get a 1 if you turn in basically anything, but if you ignore a bunch of directions. A 2 is a decent effort, but there's some issues like errors, things, or has problems knitting, or just, doesn't look like what it asks for, like you don't hard code stuff. 3, you did a good job. You nailed it, right? That's about it. So there's a question to me. Do you have a preference for how files are named? No, actually, one of the great things about Canvas, and the reason I have you load up HTML files, I don't even have to download the files. It will render that HTML file right in Canvas. So people don't have to download anything. The file names don't actually matter. They'll be displayed in Canvas. So yeah, that is it for today. So if you have more questions, you can stick around and ask me stuff in chat, shoot me emails, anything like that. Good luck for it. There will be a lab on Monday to walk through things, anything you need. Same bat time, same bat place. Thanks for showing up. Hope we have a good term. Okay, questions. Yeah. So peer grading is due at the same time following homework assignment. So yeah, the way it works is that you'll turn in your homework on Tuesday, and then the peer grading assignment will go out the following day, and then you have until the next homework is due to turn that in. So they're always kind of staggered. You'll have the peer grading of the previous week. Yeah. Okay. Also had a question just in chat. When do you plan to post recordings of lectures and labs? As soon as they're processed, pulled down to my computer and uploaded to YouTube, I will post them up. That will vary in time depending on how busy I am, but I'm going to do it pretty fast. Another question I just got was the package that you used to move Word docs back and forth from R Markdown called Redoc. I think it was. I only caught it on Twitter. I've never used it myself, but it looked really cool, and it was the kind of thing I would totally use. I think it's Redoc, though. Yeah, I think that's correct. Okay. Anything else? Yeah, absolutely. Give me about 5 minutes, and sure.